Hello everyone, we have the group number 4 and this is our project. Next please. The company we are working with is the IPAC, a metallurgical company that is dedicated to sell of profile, covers, collaborative plant, and the product we will focus on will be is the galvanized steel sheets. Next, remember the definition safe. We have the variable G, that is the reduced cycle time and ensuring product quality, which depend the following variable is the X1, 2, 3, 4, 5. And furthermore, this is our definition of the problem, and this is the general objective of this project. Next, we will help the Minita. We find the distribution of the variable where a greater ID and the p-value is greater than 0.05 represent a good distribution. As we can see in the graph, the same applies to the each variable. It is the word hive lifting that this activity as the sum of the some valid activity for the company, and the same applies for the each variable. Next please. Next. Continue with the video. I have to record it like this because my computer did not render the recording while the production was running. And the process begins with stalking the coil to the wear area, remove the protection, and place it in the coil holder belt. Make the cross cut and make the vertical cut, and then it is the packet. The final product is labeled, and the ghost is the PT area. All this which is the overhead crane. We can next the slide please. Next slide. And we can see the approval by the engineer Yoshiro. Next, and then the validation which is the flexing experiment, and where which p-value of the 0.1H3 the simulation means does not differ from the real mean, which is the real data. Next, which the statistical tool, we can see that we need a 50 simulation. Thank you.
Okay, based of the analysis of the Pareto diagram, the main potential causes of the problem have been identified, which are disorganization in the area, lack of automation, poor quality practice by operators, poor maintenance of machines. We can see before we can see the proposed solution to these problems. Next, now, based on the cause-effect metrics, the implementation of the SMED tool in the production line and the implementation of 5S in the production line and in the warehouse area had been selected as effective and economically feasible improving proposal. Next. On the other hand, we can see Gantt chart of the activities of proposed solution. To carry out the implementation of the 5S in the warehouse, we first held a meeting with the warehouse manager where we established a 5S committed and planned activities to be carried out. Next, first, the classify stage, which consists of classify warehouse elements such as codes and materials with red cards according to the frequency of use, importance, relevance of the equipment, and amount. The other stage is organized, which consists of identifying the best location for the types of codes. The cleaning will be done later with designing employees of each stations will supervise keeping the warehouse clean up and keeping everything in its place. Then the stage of standardize the process will begin. Finally, do an internal audit will be carried out to monitor the compliance of the activities. Next. We can see here how the warehouse will look with the implementation of 5S.
Another improvement proposal is the implementation of the 5S methodology to the production line in order to obtain multiple benefits such as efficient improvement reductions of preparation times, error prevention, safety improvement, production quality increase, cost savings, and facilitation of continuous improvement.
Here we have the activities time. We have the type of activity, that is internal activity and external activity, the description. For example, turn off the machine, remove the circular blades, prepare tools and equipment before shutdown. In others, also the time in seconds. Next, please. And this in this table, we can see the summary of the activities mentioned. In total, we have 510 seconds of the process blade calibration. And we will try to apply SMED to reduce this time. Next, please. Here we have some points, important points to reduce this time. For example, the visual inspection during operation, the standard producer for calibration, the investing in precise calibration technology, and the correct use of tools for this calibration. Next, please. After applying this, we can see how some internal activities change to external activities. That's the purpose of the SMED methodology. As we said, next please. And in this table, we can compare this time in seconds. For example, the non-SMED, we have 510 seconds, and with SMED, 343 seconds, obtaining the result that we want. Next, please. Here we have the evidence.
And this is the next step that include in control and the that material that use. Thank you.